Have you ever stopped and wondered how your phone just knows it's you? Or how a self-driving car can tell the difference between a person and a lamppost? Well, it all boils down to one of the most amazing tricks in artificial intelligence, teaching a computer how to see. And today, we're going to pull back the curtain and show you exactly how it's done.
I mean, look at this. For you and me, it's obvious, right? That's a cat. But for a machine, this is a mind-bendingly complex puzzle. How on earth does it learn to tell a cat from a dog or, a coffee mug from a keyboard? We are going to break that down step by step.
All right, so let's start at square one. Before a computer can make any kind of smart guess, it has to figure out what it's even looking at. And trust me, the way a computer sees the world is nothing like how we do it.
Yeah, you heard that right. A computer doesn't see a cute furry cat. It sees a giant spreadsheet, a grid of pixels, and every single pixel is just a number that represents its color and brightness. A single photo from your phone, that could be millions of numbers. The real challenge is finding the hidden pattern inside that ocean of data.
So this is what it all comes down to. Image classification, at its heart, is about teaching an AI to take that massive grid of numbers and slap a simple, human-readable label on it. Cat, dog, car. It sounds basic, but this one task is the engine behind countless AI applications we use every day.
Okay, so how does an AI go from millions of pixel values to a one-word answer? It's not magic, it's math. It learns a kind of mathematical translator that can turn all that numerical chaos into a clean, simple answer.
The entire goal here is to find the perfect function, let's just call it f, that takes the image's numbers as the input, does some magic, and spits out the correct label as the output. When you hear deep learning, a big part of that is just building a really, really good function that gets this mapping right almost every time.
This whole process can be broken down into a few key steps. First, the AI model, which is often a special kind called a convolutional neural network, literally just eats that grid of pixel numbers. Then it starts looking for patterns, simple things at first, like edges, corners, and textures. After that, it weighs all the evidence it's found to make a final decision, and then boom, it gives you the output label.
But here's where things get really interesting. Not all classification problems are the same. See, the type of question you're asking the AI actually changes the entire way you have to build it. Just think about it for a second. When you look at a photograph, is there always just one correct answer for what's in it? The answer to that question is what splits image classification into two totally different worlds. And this brings us to a super important idea. On one hand, you have multi-class classification. Here, the answers can't overlap. A picture of the number 8 is an 8. It can't also be a 7. But then you have multi-label classification, where an image can have a bunch of correct labels all at once. A single photo could easily have a dog, a ball, and a park in it, and all of them would be right.
Let's really hammer this home. For a multi-class problem like reading a handwritten digit, the goal is to pick the single best answer. But for a multi-label problem like, say, analyzing a chest x-ray, the goal is to pick all the things that apply. A patient could have both pneumonia and an abscess, and you absolutely need your AI to be able to spot both of them. It's a critical difference.
So, this brings us to the technical secret sauce. We need some kind of mechanism, like a mathematical switch, that tells the model, hey, for this problem, give me just one answer, or for this one, give me all the answers that fit. How does it know what to do? Well, the answer lies in the very last step of the neural network. There's a special function that takes all the model's raw scores and turns them into probabilities we can actually understand. And believe me, the choice of which function to use is everything.
And here they are, softmax and sigmoid. Think of softmax as the one for multi-class problems. It looks at all the possible labels together and forces them to compete. It turns their scores into probabilities that all have to add up to 100%, basically forcing it to place its biggest bet on a single winner. Sigmoid, on the other hand, is for multi-label. It treats every single label like its own little yes or no question, giving each one an independent probability.
Let's make this real. Imagine we're classifying that handwritten digit. A softmax function might look at the evidence and say, okay, there's a 90% chance this is an 8, a 5% chance it's a 9, and a 5% chance it's a 7. Notice how they all add up perfectly to 100%? To be really sure about 8, it has to lower the probability for everything else.
Now let's flip to the X-ray example with the sigmoid function. The model can look at the scan and say, there's a 92% chance of pneumonia and an 88% chance of an abscess. Each one is a separate prediction. The probabilities don't affect each other. The model isn't forced to choose just one, which in medicine could literally be a lifesaver.
Okay, now let's take all these concepts and see how they come together to do something truly world-changing. This isn't just theory, this stuff is being used right now to help save lives.
A really powerful example is happening in ophthalmology, that's eye medicine. Researchers are training AI models on thousands of complex retinal scans, called OCTs, to spot diseases that can cause people to go blind.
In one incredible study, a model was given a multi-class task. Its job was to look at a scan and classify it into one of 4 distinct categories, 3 very specific diseases or just a normal, healthy retina. So the goal was clear: pick the single most accurate diagnosis for that patient's scan.
And the results? They were just incredible. The best model hit 98.7% accuracy. Let that sink in. That is a level of precision that shows just how powerful AI can be as a tool for doctors, helping them catch these awful diseases earlier and more reliably than ever before.
And look, don't just take my word for it. As researchers in the field put it, this isn't just a small step forward. This deep learning revolution is opening up a whole new world of possibilities for how we diagnose diseases and take care of patients.
And all of this leaves us with a really fascinating and maybe even a little bit of a scary question for the future. As these AI models get better and better, sometimes even more accurate than human experts, how do we weave them into our lives and our hospitals? The technology is here, and it's making us think really hard about what expertise and trust even mean anymore.